All right. So for problem number three, the business problem is that there's a company who's having communications issues, so they want to upgrade uh, their internet to get so the communications better. So they spend the first month with education, second month bringing the sales team, third month manufacturing, month um, was fourth month was where getting it in the warehouse, and then the fifth month was marketing. So um, the first portion of it is that we have to solve the best way to buy a server each month, meaning that um, from month 1 and 2, we need to get the sales team, which is 60 people. Month 3, we need the manufacturing, which is 200. Month 4 is warehouse, which is 75. And month 5 is marketing, which is, oh no, month 4 was 30, month 5 was 75 for that. So how we did that was we minimized the cost of the servers, and in the first 2 months we get a discount for um, the 202,000 person server, and then we set the constraints to make sure that they could easily get the number that we want. And we also have this constraint for the first 2 months because this is the budget we have for the first 2 months. So month 3, same thing, but this time there's no limit on the server. There's no discount, so the price did go up, and we need to now get 200 people instead of just 60. Month 4, same thing, but we only need 30. And month 5, we need 75. So the optimal solution for this was you get either two units of server 1 or 1 unit of server 2 in months 1 and 2. You get 1 unit of server 3 in month 3. In month 4, you get just a single server of the first server, the 30-person server, and for the last one, you get just a single 80-person server. So the optimal solution, your cost would be 22,500 with one single person, one 30-person server, two 80-person server, and one 200-person server. And so for part B, this is kind of interesting, which is kind of looking at what happens if instead of having, all right, we buy on a month per month basis, we buy as many as we can. So there's two different things here. So these 4 variables are the servers from month 3 and beyond, and these 3 variables are the servers from the first 2 months. And because we don't have there's not enough room in the budget to get server 4 in the first 2 months, we don't have the variable for that here. So we want to minimize this cost function, in which the constraints are we need at least 60 people in the first month. We need to limit our cost to under 9,500. And we also need to figure out how much servers we need to buy after in months 3 and beyond. And so what we pretty much have is that we have these 4 variables are greater than or equal to 365 minus whatever we bought in the first 2 months. So if we bought, let's just say, a unit of server 2, then that would be 285. So the constraint just changes with this one. And we get the optimal solution for that to be um, we should buy um, one of the 200-person servers in the first 2 months, and then another one in month 3, so that the first month, the first server only has 60 people. You buy another one for the warehouse, or not the warehouse, the manufacturing. So then that server's full. And then when you get the 30 people from the warehouse and the 75 people from marketing, they just go on to the server that's already there. And that gives us a cost of 19,000, which is a lot cheaper than what we previously had. And so part C, we kind of the reason these two are different is because part A just all right. He kind of breaks it down to all right. You buy us the cheapest option just for this month, for month 1 to month 3, month 4, and month 5. So well, part B is like all right. Buy us something, buy the cheapest option, but keeping in mind that any leftover we have from the first 2 months, we could use in the future months. So that's kind of what it is that one of them is one of them it's kind of you're treating each server as independent, like you're designating one server or one group of servers for each department. While part B kind of says, all right, we can multitask these servers to kind of spread it across it and minimize costs that way. So that's why the two answers are a bit different in part A and part B. Part D, there's a couple of different costs that Sarah isn't looking at. There's the training, there's the loss of production because the people aren't working. There is training costs, there's maintenance costs to maintain the servers to make sure that this communication network still works, or else you're back to the old system that clearly doesn't work. And then part E, I guess I didn't really explain the context too much, but just real quick on the context is that manufacturing is just printing out a bunch of pagers, where they have a surplus of pagers, like way more than any order accounts for. But sales, they don't get them, so they're behind on orders. So what ends up happening is they're behind on orders, and they just have a large stockpile that they can't move. Well, some of them they can move once they realize where the order is, and then the other ones just kind of sit there collecting dust because they didn't actually communicate well enough to figure out that, oh, we only need to make this amount. So different kind of concerns for departments might be that security of the system, that's always going to be kind of a concern with any sort of intranet. There's people at people are just bad with technology, or stuff like that. They could take a bit longer, so this could actually have some hiccups to where the communication might not be great at first because of these things. And there's also the concerns that, all right, maybe we can downsize manufacturing because we reproduced way more pagers than we actually needed, than sales actually was able to sell. So maybe we only need, let's just say, 175 employees to fulfill the orders in a reasonable time, and instead of having all 200 employees, or maybe just stuff like that, to where it could just take a little while and stuff like that. So yeah, and that is it for problem 3.